Welcome to Horizontal Drilling Sins, part of the Revolution in Horizontal Wells Drilling series. Well, understanding is the key. What is the horizontal sweet spot? Well, for geoscience teams, the sweet spot in unconventional formations is where the production of hydrocarbons has created natural fractured zones. It's what we like to call Mother Nature's oil veins. In this classic example, you can see chalk outlines of these oil veins at the surface in the Marcellus Shale. Let's get a closer look at them. You can see the natural veining and fractures that have taken place. They even look like plant roots. Well, so then, what is the key to horizontal well production? Frac in the sweet spot connects nature's oil veins and turns them into arteries for the oil to flow. So the sweet spot equals production. Well, if Geosciences knows about the horizontal sweet spot, why are wells more productive? And why are 60% of frac stages ineffective? Well, that brings us to the horizontal drilling sins. Two key roles are working against you. You guessed it, geology and engineering. Of course, we have drilling in there as well, and one key role doesn't work for you at all. So let's look at the geology side first. Okay, vertical versus horizontal logs. In a vertical log, they have these markers that indicate formation tops. I see this one in the rabbit ears, but when you look at it horizontally, it sure looks a lot different. So we end up marker hunting. And marker hunting kills production. Sensors are back at the bit. See, they have to go out of the zone to prove that they're in it. So we're constantly drilling out of the zone to prove that we're in the zone. So let's take a look at this typical example. See, first they're sent into the zone, see the marker, then they steer us out of the zone, end up losing about 300 feet, see that other marker, then they turn back in, crisscross all the way to the bottom, you guessed it, out the bottom, then they lose another 400 feet, and then they come back in. It's over 700 feet lost due to hunter marking, and worse still, look at how much steering had to be done to accomplish that. All that wear on the BH sheet A and Y. Look around, because bottom line is ROP. So if geosciences find the sweet spot, as outlined here in this little green window, drilling engineers, well, it's hard for them to trust the geosciences because geosteering appears to always be lost. They're marker hunting. And so, if they try to do a small zone, they think, wait, it's going to be too expensive. Why? Because they'll be constantly steering in and out, in and out. Well, they can't have that. So they said, all right, let's just have some bigger windows. Besides, it'll all frack anyway, right? Well, geology doesn't complain because, hey, they get to see more markers, and the end result is this. Is it any wonder why we've got a production problem? So drilling engineers, would you be willing to give up one drilling day to make 20% more production? You're right, that's the wrong question. The right question is, why can't I drill faster and have 20% more production? So now you understand what it is we do. So, would you rather read the lines, waste the footage, waste the time, or would you rather speed between the lines? As we do with our surgical geo-accuracy, directional zone threading, I mean, come on, look down here, there's a lot less steering. So, how does this all come together in this ends? Well, production, destruction. Let's look at a case study of it. 3 middle Bakken horizontal wells, same pad, completed at the same time. Very large operator, and marker hunting is killing their production. And then we're going to show you our solution. So let's take a look at this example well. You can see what we did. Managed to thread the top, went down, threaded the bottom, went to the middle, and ended up going out down into the bottom again. You can see here all the different times that we went marker hunting. And the last one's quite interesting because they really wanted to get this well done fast. And so at this point they made the decision to go down and let's get back in that better drilling, and we finished out the well there. Besides, hey, we'll all frack anyway, right? Well, let's look at what we managed to learn there. We've got a lot of data through our zone threading reports. Because remember, we were able to thread Zone A, Zone B, and Zone C. Be able to drill between those lines. And what did we learn? Well, we got BHA performance by zone. True ROP and our BHA directional response analytics and drilling mechanics analytics allow us to get this type of data in our zone threading reports. But this data is only valuable, can only help you if you know about where the sweet spot is. So let's look at our production results by zone. Well number 2, fantastic well. Did it a day and a half faster, everyone got a bonus, everyone's happy. Well, how did the production go? And yeah, you guessed it, it was the worst performer of the lot. Why? As you can easily see by looking at Zone B. Let's draw out the comparison there of percent in zone to how many barrels. It's practically a 1-to-1 comparison. For every 1% more in zone, you get 1% more in barrels. So let's take a look at that well one more time. Armed with this knowledge, we'll draw in the sweet spot, and it looks terrible, especially when you look at this ROP decision. Remember that one? Well, how much did it cost us in production? Ouch, 28%. Truly, this well was the fastest loser. Like we said, we have a solution to this. Our solution is to optimize in zone B. We know about the 1% and 1%, so we use directional zone threading. We threaded each of those zones, so we know we can increase footage in zone B by up to 90% or more. Also, with our drilling mechanics knowledge, we know how to drills in zone. We know how to optimize the parameters there, and we've also learned what their directional response is. So this leads us to BHA optimization. Now, the BHA, when we were drilling the 3 wells with the highest performance in that zone, was this, but we know with our improvements to it, we could easily increase that up to here. So what does that mean? It means that we have a predictive model with our knowledge of the zone. Now, we know that marker hunting averaged 55.1% in Zone B on all 3 of those wells and 14.4 drilling days. Well, with what we learned, our next Bakken well, 13.5 drilling days, 90% plus in Zone B. If we stop hunting for markers and take advantage of the speed between the lines and the increase in production that follows, that is what the Revolution drilling system is all about. With our surgical geo-accuracy, directional zone threading, BHA optimization, mud engineering, and drilling mechanics. Improve your well economics and lower your drilling costs with the Revolution drilling system. Contact us for more information. We are the IDD Group. Thank you so much for watching.